Okay, so you guys don't remember my favorite saying?
No.
You don't at all?
No.
Oh my goodness gracious. Okay, let's try it. Let's try it. Same side. Oh my goodness. Did I not?
No, you never told us. You did. Yes, you did.
Maybe I didn't. I'm sure I did.
You did.
Oh yeah, see, he remembers. Okay, so same side, simplify. Opposite side, opposite operation. Okay? So same side, simplify, opposite side, opposite operation. So all of this stuff, parentheses, fractions, are both sides of the equal sign simplified. That's all same side, simplify. Specifically, if I have parentheses, what do I do to get rid of them? Distribute, right? I multiply it into the parentheses. What if there are fractions? How do I get rid of them? Multiply by what? By the denominator. Good. So if I have parentheses, I get rid of them with distribution. If I have fractions, I multiply by the denominator. Simplifying same side could also mean I have to combine like terms on the same side of the equal sign or something like that. The new thing that we're going to do today is this one right here. Are there variables on both sides? Okay, if so, I need to get them to the same side. So get to same side. How? How do I get them to the same side? If they're on opposite sides, what do we always do with stuff that's on opposite sides? Opposite operation. So I bring them to the same side with opposite operation. Okay, so same side simplify, get variables to the same side with an opposite operation, and then the constants on both sides, coefficient, all that stuff is opposite operations again. So really it all breaks down into same side simplify, that goes for parentheses, fractions, combining like terms. I get the variables to the same side, and then I can start solving using opposite operations, okay? All right, so let's look at some problems. We're actually going to skip 1 and 2 because those are problems that we've done in the past that I already know we know how to do, okay? So let's look at 3. Have I simplified, or are both sides already simplified? Yes, there are no like terms, there are no parentheses, no fractions. There are variables on both sides though. So I need to get them to the same side. So here's my disclaimer. There is no right or wrong way to do this. There is no right or wrong side to take your variables to. Sometimes you might want to take them to the left, sometimes you might want to take them to the right. There is generally an easier way and a harder way, but there's never a right or wrong way. So don't write anything yet. Let me ask you a question. Do you think it's going to be easier to take the 2x over? So minus 2x, 6x minus 2x is 4x. Or do you think it's easier to do it the opposite way? So if I take 6x over, so minus 6x, 2x minus 6x is negative 4x. Who said that? Okay, Mariah, why do you think minus 2x is better?
Because then if you subtract 2 from 6, it's a positive number.
Okay, so do you guys like negatives?
No.
Neither do I, so let's avoid them, okay? I'm going to avoid it by always taking over the smaller number. Okay, and keep in mind, if it's negatives, it's obviously opposite of that. But here, I want to take over the smaller number, so I'm going to subtract 2x. That's just what I would personally choose, okay? Again, it is not wrong if you take the 6x over. You'll still get the same answer. It just might be a tad bit more difficult, okay? All right, so let's keep going here. So if I subtract 2x from both sides, 2x minus 2x is obviously gone. I'm left with 5. What is 6x minus 2x? 4x and minus 4. Okay, so I have variables to the same side. If you need a paper copy, they're over here. Or you can use the web-based version, like all the smart people do. Told you don't use. I told you not to use the app. Okay, we digress. Let's keep going here. All right, so I need to solve now that I have variables to the same side. So I'm going opposite sides. So opposite operation. I get rid of negative 4 by adding 4 to both sides. I get 9 equals 4x. 4x is what again? 4 times x, so I get rid of it by dividing by 4. I get x equals 9/4. Okay, you guys do number 4 together in your groups. Go ahead. Can I see by a show of hands how many people took negative 10x to the other side? Okay, can I see how many people took negative 6x to the other side? Okay, so we're about half and half. That's fine. That's fine. Remember, there is no wrong way, and I want to show you that. Okay, so I'll start off the first time. I'll take negative 10x to the other side. Taking negative 10x to the other side is probably the easier route, but that's okay. Because when we're talking easy, we're really talking whether you're going to divide by a positive 4 or a negative 4. I mean, it's not really that different. So I subtract 21 from both sides. I have negative 4 equals 4x. Divide by 4 on both sides, and I get x equals negative 1. Okay, alternatively, what if I take negative 6x to the other side? So I add 6x to both sides. Guys, please, come on. So I have negative 4x plus 17 equals 21, and this is gone. Subtract 17 from both sides. I get negative 4x equals positive 4. Divide by negative 4 on both sides, and I still get x equals negative 1. Okay, so it really doesn't matter which way you do it. There's one method that will get you a positive x versus a negative x, but it doesn't honestly matter. Okay? All right, let's get a little bit harder and flip over to the back. Or whatever. Okay, I want you to do, together with your partners, I want you to do 4 and 6. So skip 5. Do 4 and 6 together with your partners. Go ahead. Any questions on 4 and 6?
What are the special cases for?
We'll get to special cases in a minute. Any questions on 4 and 6? Confused on 6. What are you confused about on 6? Okay, so let me just redo it. Okay? All right, so here's 6. So I have multiple denominators. Remember, I have to get rid of them by multiplying by something. So I need to figure out what would go above a 3 and above a 6 that would clear both of them. A 6, right? So I choose 6, and I multiply every piece by it, even the whole numbers. So 6 times 3 is 18, minus 6 times g is 6g, divided by 3 is 2g, so I have minus 2g. 6 times g is 6g, divided by 6 is a single g, and then 6 times negative 8 is negative 48 or minus 48. Then I'm just solving from there. I bring variables to the same side, so plus 2g plus 2g. So 18 equals 3g minus 48. I feel like a Verizon commercial right now. Add 48 to both sides. 66 equals 3g. Divided by 3. And g equals 22.
3G.
Okay, questions? All right, what is the next little section titled? Special cases. So they're going to be special. That means they're going to be weird, okay? There are going to be different things that happen that aren't normal, that don't happen in normal problems. So I don't want you to be like the damsel in distress and say, Mr. Craw, what's going on? I don't know what's going on. Okay, I don't need that. We don't need that. All I need you to do is do what you know how to do. Do what you are, be confident about what you're doing, okay? Something weird will happen, and that's okay. When you get stuck and can't really figure out what else to do, just move on to the next one. We'll come back and look at it, okay? So go ahead. Okay, guys, I've done a little bit of simplifying here. I've simplified same side. Now I need to go opposite side, opposite operation. So on number 7, I need to bring my m's to the same side. So I would subtract 4m because I need to do opposite operation. What's 4m minus 4m?
0.
Nothing, right? So I have negative 1 equals, again, 4m minus 4m is 0, so negative 1. What is weird about this problem? Bye-bye variable, right? It doesn't have a variable. This does not mean the answer is -1. The variable is gone. It's not x equals -1. At this point, once the variable drops out, you know it's special. You have one question to ask yourself. Is it true? Is what's left here true?
Yes.
Yeah, -1 does equal -1. Since it's true, this is called all real numbers. Okay, and the reason the answer is all real numbers is because since the variable dropped out, that shows us that no matter what I put in for m, it will always be true. Any number would be a solution to this equation. Okay? Most equations just have one single solution. This one doesn't. It has very many different solutions. Okay, let's look at 8. Again, I need opposite operation to get rid of my variable, or to get my variable to the same side, so I subtract 6x. Again, the variable drops out. This time I get 12 equals 7. So again, one question to ask yourself, is this true?
No.
This one is not true. That means no matter what I plug in for x, it will never be true because it will always end up being 12 equals 7. Okay? So that means this is no solution. Okay, so there's a normal one answer kind of equation, and that's probably 95% of the time. If you hit a special case, it's either, hey, I solve down, my variable drops out, it's true, that's all real numbers, or I solve down, my variable drops out, and it's not true, that's no solution. Okay? All right, one more thing to show you before you have some homework time is literal equations, okay? What if I have have an equation that has more than one variable in it, like number 1? Okay, well, it will always tell you what to solve for, and I want you to always identify that first. So on number 1, what do we need to solve for? Y. So circle it. Just so that you're not confusing yourself. We're solving for y, so I circle it. So what does that then mean that we need to get rid of? X and? No, r's already away from it. X and 4, right? Every other variable other than the one that we're solving for, every other variable we treat just like we would treat numbers. So if I had a number sitting out in front, how would I get rid of it? When I say out front, I mean out here, like this x. I would subtract it, right? Because it's positive x. So opposite operation would be subtract x. Subtract x. X minus x cancels each other out. I'm left with 4y equals, and on the other side are the letter r and x like terms. No, they're not. So I can't combine them. I just write them. I just write just what I see. So what do you see on the right-hand side? R minus x. So that's what I write. R minus x. Just like that. Okay, again, I need to get y all by itself. So now what do I need to get rid of? 4. So what is 4y? What is 4y? 4 times y. So how do I get rid of it? Divide both sides by 4. And there's my final answer. Y equals r minus x over 4. Don't be scared of these problems, okay? Kids always want to try and combine way more than they actually can. These answers are not like a nicely little packaged number like they normally are, okay? They're messy. There are multiple variables that you have to deal with. The answers aren't just nice like they normally are. Okay, let's look at one more of these. Let's look at number 4. Okay, so first identify what you're solving for and circle it. So I circle B. What then does that mean I need to get rid of? 2 and H, both of them. Which do I get rid of first? 2, because remember my flow chart on the front side, it told me to get rid of fractions first. How do I get rid of that fraction of a denominator of 2? Multiply by 2. So 2 times. On the other side, 2 times. So 2 times A is 2A. My 2's cancel on the right, and I'm left with just BH. What is BH? B times H. So I'm trying to get B all by itself. I need to divide by H on both sides. So there I have it. B equals 2A over H. They're not really that hard, but they get kind of confusing with all the variables, okay? If you just do exactly what you would do if it was a number and don't try to combine too much, you'll be fine. Okay? All right.